Alright, picture this. You've got 50 servers staring back at you like hungry toddlers at dinner time. One squinted for Apache, another lost its logs, one forgot its firewall rule, and another one just blinking suspiciously like it knows it's about to break. And then your boss walks in all calm like, "Hey, can you fix all of them right now?" Right now? Unless you've got superpowers or 10 clone versions of yourself, logging into each one manually is cloud torture. But then, cue the hero music. Enter AWS Systems Manager. This thing is basically the universal remote controls for all your servers. You don't have to jump into each one like a tired system admin ninja anymore. Now, instead of doing everything manually, SSM lets you create what's called a document. Think of it like a recipe cards for your servers. You write, install Apache, configure the firewall, send logs to CloudWatch. And instead of repeating that recipe 50 times like a broken record, you just click Run Command. Boom! SSM takes that recipe, delivers it to every server, and handles that chaos while you sip your coffee pretending it's magic. And the best part, everything it does is logged in CloudWatch. So when the security team comes asking, "Who touched my server?" you can smile innocently and say, "Not me, blame SSM." What's the big deal anyways? It saves you time. No more typing the same thing across 50 SSH windows like you're typing a competition. It reduces mistakes. Every server gets exactly the same setup. No oops, I forgot to enable the firewall moment. And another one, it keeps you compliant. You can prove what got installed and when. Auditors love that kind of drama. Basically, SSM turns chaos management into cloud management. Alright, now let's look into this real world example, the fintech panic. Let's say a fintech company run payment apps on AWS. They need Apache on every server for their dashboard and CloudWatch logs for monitoring transactions. Suddenly, someone shouts, "The dashboards are down. Update all the servers." Now, a rookie would panic and start logging into each EC2 instances manually. But the cloud security engineer with SSM just smiles. Create one SSM document, that's your recipe. Hit Run Command and watch it roll out to every server at once. Done. Consistent, secure, and logged. While everyone else is sweating, you're sipping your drink saying, "Relax, I've got SSM." Now, instead of just talking about it, let me show you how I'd handle these client servers before my coffee even gets cold. So welcome to my console once again, and we're going to continue from where we stopped from the 3 instances that we created. So we are going to install an HTTP server. That is the first step that we're going to be doing. Remember that when this was created, now if you have not seen the video where I created these instances and attached a tag and grouped them in a resource group, please go and see my video on tags and resource so that you can have a proper understanding on how I'm going to do this. So if you can remember, in our security group, we did not install an HTTP server, and that is what we're going to be doing right now. Okay, but the first thing we're going to be doing is we're going to go to security. Security is just right here, but let's start with the very first instance. Security is right here. So we're coming to security now, and we are going to edit our inbound rules. Okay, so waiting for this to load. Okay, so we are going to click on this security group here, and we're going to edit our inbound rules. So we'll come over to edit inbound rules, and the reason that we're going to be editing this inbound rows is that we're going to be giving, like I said, we're going to be installing an HTTP server. And one way that we can do that is to add HTTP here. So come here and add HTTP. So when we come over here, you see HTTP. So we can just pick anywhere. This is not a good idea, but because we're still experimenting, okay? And port 80, all right, then save rows. Okay, so our inbound row has been modified. And now that we have done that, we're going to proceed to now creating our document. Okay, so we're duplicating this, all right, because you know that I love me a little more room to be able to do my stuff. Okay, so this is where it's about to go down. Now that this has been created, can just come over here and type SSM because we want to create documents now. And over here, all right, so we're going to go over to documents. Should be somewhere here. Okay, so this is documents. All right, so we are in the documents session and there's a lot of documents, but all of this are owned by Amazon. So there is like the AWS, ASG, Enter Standby. I mean, I can't wait to make use of all of this ones. There's like the Apply, Ansible playbooks. Okay, there's the Apply Chef recipes. Okay, there is like the Attach EBS volume. This sounds familiar. There's like the Archive EBS volume snapshot. I mean, there's a lot of them here, but we're not going to be using anyone owned by Amazon. We're going to be creating our own document ourselves. All right, so we come over here to create documents. We're creating a command or session type. So we're going to be giving our document the name of install Apache. All right, and target type EC2, obviously. EC2, we'll stick with the command. And for the content, we have the JSON and we have the YAML. The YAML. Okay, but I'm going to follow what the tutorial that I did taught me. And one of the things he said was that JSON is good, YAML is good, but YAML is actually simpler and more easier to understand. And we're just going to be making a few changes here in the YAML section, and you can always find that in the SSM directory. But for this particular tutorial, I would attach what he used, okay, and I just copied it just to make my work easier. I think I gave it SSM directory. All right, directory. Okay, let's search directory then. Okay, this is the directory. All right, so we open this. That is opened, as you can see here. So we just copy all of this, Ctrl C, and we just paste it. So as you can see now that the schema version is 2.2, our description is sample YAML template to install Apache. That could be anything. Parameters are like a message, strings, you know, a description record message. default hello world. Action, we're running a shell script, configure Apache, and the rest is history. So we'll come over here and create document. Okay, so I created this already, but let's change the name so that let's see if it'll be different. So create this document. Okay, that has been created. I created that although when I was practicing with the hands-on, but this has been created. Now that that has been created, the next thing we're going to do, right, is to go to a document owned by me. All right, so this was one I created yesterday, and this was the one we just created today. So when we open this one, so as you can see that the description, just as we included in the YAML code, install YAML templates to install Apache. Our platform in our institute is the Linux created here, owner, blah, blah, blah. So we're going to proceed now. Now that we've created our documents, we're going to be running this command, okay? Okay, so we've gotten to run command. Now that we are here, we're going to click on run command here. And we're going to find the documents we just created. So we'll search by owned by me. Remember the one we created, which is this one. And the next thing that we're going to be doing is, all right, so for our document version, we're using the latest version at runtime. For our message, we can customize this message or just leave it be as hello world. I'm not going to be touching that. I'll leave it as hello world, okay? We have like the specify instance tags, choose instances manually, choose a resource group. But for this particular one, let's choose our instance manually. Okay. All of them is good. We just select all three of the instance. Okay. So comments, I don't think I want to write anything there. There's no need for that. For a timeout, let's just leave this as default. If we expand this rate control, we'll see that our target, let's keep our target as 1. So we selected 3 instances. Let's just give it a target of 1. If we read it, we understand that specify the number of percentage of targets on which to execute the task at the same time. So 1 at a time is okay. And for our error threshold, 0. So stop the task after the task fails on the specific number of percentage of target. Or stop the task after the task fails on the specified number of percentage of target. So we're going to leave our error as 0, okay, because we're still experimenting. So you can keep it as 1. So it could be that when you notify one error, you can stop the percentage of, you can stop the execution. So when you can keep it as 1. That is when it notices one error, you can stop the execution. But that, I'll just leave it be as 0. Okay. So enable an S3 bucket. So for this particular hands-on, we're not going to be using an S3 bucket. If you remember the first video that the part 1 video of this SSM playlist that we did, the first one about tags and resource group, I added a policy, a CloudWatch policy, and that is what I'll be using here and not an S3 bucket. So our enable, I'm going to enable a CloudWatch log here, and we can give the lock group name as, let's say, SSM Doc CloudWatch. Okay, so you can decide to give it whatever name you want to, but I'm choosing that. Our alarm, I think we're good. So now that that has been said, can proceed to running this particular here. Okay, so we got the command ID was successfully sent. So we are waiting for this instances of ours to show that it is successful. That is the status here to be successful. So we can come here to refresh. When we refresh, wow, all three are now successful. So we can click on any one of them. When we click on the first instance, all right, we can see that the error under the error here, the only error we got here is that a newer release of Amazon Linux is available. The available versions, blah 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 blah, release note, warning, okay, created system link, okay. What if we check the output? So the command output displays a maximum of 24,000 characters. You can view the complete command output. We're going to be doing that, but let's just check this out. Nothing to do, complete, okay, dependencies resolved, package arc version. Okay, so we can see that our package arc version, repository size, installing our HTTPD, installing dependencies, okay. All right, install 12 packages, downloading packages. Okay, installing. So, installed. So, like it said, we can view the complete command output in our CloudWatch logs. All right, so we can see now in our log events. I mean, we wouldn't be able to see this if we did not attach that policy when we were attaching the IAM role at the first video. And we can see every other thing here. I mean, you can see everything else, the package, almost the same thing we saw there, but this is a bit comprehensive. Nothing to do, the package, everything else, installing, the total download size. So we see them here in detail. Another thing is that if we come over here and copy this public IP address and paste it in our Chrome, I hope it doesn't disappoint us today. All right, so we can see here that hello world from the host name. So meaning that everything is working good. Everything is working perfectly. A CloudWatch loss is giving us the results we want. You know, everything is good. So next time someone screams, update everything now. Don't panic. Channel your inner cloud whisperer and say, no worries. AWS Systems Manager on babysitting duty. Now, if that made cloud security finally make sense and even made you laugh, hit subscribe and don't forget to like this video because we're just getting started.